Yeah, cheers everyone for coming. So yeah, obviously my name's Sam. I work for Corecom on the test markets. Obviously place sort of testers around the north, and yeah, essentially specialise in the permanent side. George, who's my colleague, yeah, there he is over there. He specialises in contract. But yeah, today obviously welcoming James. So James has done a few sort of talks beforehand, mostly internally with a few external things coming up. But obviously he's taken the time out today. So thank you very much for that, James. But without too much of an intro, I'll pass you over to James so he can talk more about himself and obviously what he's going to be discussing. So won't take too much thunder away. But yeah, I'll pass you over to James in his very capable hands.
Oh, cheers, Sam. I'm going to try to share my screen better than what I did a minute ago. It took so long. Right, there we go. Can you see that?
Yeah, it's perfect.
Awesome. Cool. So yeah, I'm going to be talking about continuous deployment today, the what, why, and how. But firstly, I just want to say a big thanks to Sam and Corecom for putting on an event like this. It's really good to keep the testing community kind of going with everything that's going on in the world. So a bit about me. I'm a lead QA engineer at AO. I work with the customer experience teams, and I've been working in software development for the last 5 or so years. I'm a big fan of continuous deployment, as you might be able to see today. So obviously I'm going to be basing everything that I talk about today on AO. So if I'll give a bit of context to AO, we have in the last week or so, I got this stat yesterday morning, we've had 1.3 million users to our website. We have 25 product teams, so we moved to product recently from project, and that's increased by 10 in the last 12 months. So we've gone through some real growth. So we've got over 300 people across AO Tech, and because we talk about continuous deployment, we do roughly 50 deployments today, every day into production. So we're going to start off with looking at what continuous deployment is, why we want to do it, and how we've kind of took steps on that journey. And the stupid little GIFs throughout because I like funny things. So yeah, we're going to start off with what is continuous deployment. So we hear often quite a lot about like CI/CD, but there's the final bit in that which is actually CDEP, the third strand to it. So starting off with CI, so that's quite a common term that's been around for a long time, which is the process of integrating changes from local like dev machines or team members' machines into a central source code repository. And then that will get built and unit test, and then that's where CI stops. That is it for CI. So then for continuous delivery, that's like the next strand after CI, which is about getting releasable software in the hands of customers by fully automating that release process. However, there is still a manual step involved with someone deciding when they're going to deploy, when they're going to deliver that software. So that could be they decide to do it every hour, every week, every month, every year. As long as that's an automated process, you are ticking the CD box. And then the final bit, what we're going to talk about today, is continuous deployment. So this is where there's no manual intervention. As soon as something's committed to the repo or source control, it goes all the way through a series of checks and tests and deployment stages to get out to customers automatically. So throughout all of this, we're going to be talking about pipelines. So when we refer to pipelines, it is the steps involved in getting that software out to customers. So as you can see here, building, testing, acceptance tests, deploying, and smoke test. So why do we want to do this? So we've done the boring definition part. So why are we interested in this? So I'm going to talk a little bit about the first time I did continuous deploying on an app around about 18-ish months ago. So I joined AO, and the first thing I was told is, we want all of our apps to be continuous deploying. And I was like, cool, that sounds like a challenge, that sounds fun. I want to win the race, and I've read about it in a book, so I can do it. Like, that's an easy one to take off, and I can get a little badge for that. So I got stuck in thinking I knew everything about it. You hear things like Amazon release every 11.2 seconds, so your head instantly goes to speed. So I was just constantly there going, how can we make this faster? And I thought the problem we were trying to solve was it took too long to deploy software. Typically, it used to take us half an hour, 45 minutes to deploy software out. And I was like, well, that's too long. We're wasting time. Let's streamline that. And that's what Amazon do. In fact, I was like totally wrong about that. And I started obsessing too much about the wrong thing. So we did get this app as an internal facing app deploying, and it was doing it straight from commit to live. And it took 21 minutes. I think we then took another sprint in like 2 weeks of getting that 21 minutes down to 15 because 6 minutes is really important. And I just completely lost focus on why it was being done. And I was just bragging about the speed too much. I was going around, and that's all. The only thing I'd quote was the speed. Where in fact, what I actually missed was the real point behind it was the feedback. So continuous deployment is about getting that feedback from your customers. When it goes all the way through, it's about getting feedback from your testing cycles. It's about understanding when things go wrong and how you fix those, so how you can quickly mitigate problems. So really, it's not about the speed of the pipeline, it's how quick you can actually get feedback on something that's gone wrong. So why do I kind of like continuous deployment? So like I said, it allows us to gather feedback from customers quickly. It allows us to experiment on things, so we can try something new. We can grab something from backlog or just someone's idea. We can very quickly put that in. We can deploy that out. We can learn if our customers are liking it or not, and we can react to that. So it very much ties into like that experimental mindset. Before that, you might have had an idea. You might have waited a long time. It might have taken a couple of days to build. You might have waited for it to go through a long test process, and you might be waiting weeks to get that feedback on just a hunch or an idea. So very much enables you to have that experimental mindset. And it allows you to share out the testing as well. So testing should not be on a person or on a function. Testing should be a team thing. It should be the responsibility of everyone within that team to care about quality. So one of the things I like is that it's just reducing the batch sizes of the changes you're actually putting out there. So that means if something does go wrong, you miss something in testing, and something does get all the way out to your customers, it's such a small change that you know it's that's gone wrong. You can roll it back, you can roll forward if you want to, you can mitigate that problem. Rather than again waiting for what might be 2 weeks, it might be a month worth of changes all going out at the same time. It's very much very focused small batch sizes. So this is actually a picture from a repo of ours for the My Account team a few weeks or maybe months ago that I just grabbed. And that one line of change there was actually deployed all the way out on its own. So it's very, very minor little things that are just out there and forgotten about. So as soon as it's done, you can forget it was a thing and move on to the next thing. So, like I said, you hear these stats about Amazon releasing every 11.2 seconds, which is like crazy to think about, crazy to absorb, and it makes you think, oh, they're just going really fast, and that's it. But actually, with that, they've seen a 90% reduction in the time to fix problems caused by a release. So again, it's following on from that idea of the smaller and the more isolated changes you can get out there, the quicker it is to fix if something goes wrong. And that's completely changed my approach to testing and how I approach work. So actually my conversation these days, and this is coming from someone who's been doing testing for 5 years, is I actually don't really care about testing that much these days. If someone says to me, we're going to just deploy this out, I'm not that scared. I'm not shouting, no, don't do that. Me 18 months, 2 years ago would have been like throwing paddies left, right, and center, like crying everywhere. But no, I don't see that as a problem now, because I'm putting the focus on how do we know when it's gone wrong for the customers. So if it does go wrong, how quick can we reduce that impact to the customer? How quick can we get things fixed? And making sure we know about it first. So HP, I found this in the State of DevOps report, I think it was from a couple of years ago, where HP have had similar success from doing stuff like this. So they've gone from 2 releases a year to having over 100 commits a day. their testing time's gone down, and actually their time spent on new features has gone from 5% to 40%. So that's a massive increase in kind of what you're doing for your customers. So again, it ties back to always think about the stuff you're releasing and the stuff you're doing for your customers. That they're getting so much more time to build new things. And again, on their lessons learned point too there, that long feedback cycles make it much harder to prevent mistakes in the future. So they've had great success with doing this as well. So now we kind of understand what it is and why we want to do it. We can look at how, and I'm going to use the little thing of like, oh, here's my 5 top tips that you can take away from this talk. So top tip number 1 is to think about testing. So I'm going to talk a little bit of a story about where I failed again. And this was about 6-ish months ago around some automation that I did. So I created a load of API testing, and it was the best API test you'd find anywhere. I was super happy with it, really proud. Came again a little bit obsessed with making it really good and constantly tweaking those tests. And the team pretty much didn't even know they existed. They were just on my machine. I would often spend time at night going, oh, look, I can change this and I can add this in. But it was very much isolated to me. They weren't on a pipeline anywhere. Like I said, the team didn't know. A new developer came into the team, put in a change, and again, my mindset of like, oh, it's fine, just push that straight out. Pushed it out, and yeah, ended up breaking our finance payment for, I think it was around about 15 minutes to all of our customers on site. And at the same time as that deployment going out, which I didn't know about, my tests were failing on my computer, and I was like, why are these failing? What's going on? What's wrong here? So actually, my test did catch the issue that he introduced by mistake, but only I knew about it, and it was too late. It was already on its way out. It was already gone. So what I learned from that straight away, and it was about 5 minutes or so after we resolved the problem for customers, I got the test straight on the pipeline and thought that these can't fail on my machine. I can't make it an isolated thing for me. It's got to fail for everybody. The big thing that I've learned from that is automated testing doesn't exist until they're on a pipeline. So if they run on a schedule every night, or if they run every week, every morning, whatever it is, or if they run on just one person's machine, or somebody might pull it down and quickly run them, they don't exist, because failures can still get around those tests. So we've got to put them on the pipeline. So this is the exact scenario I'm talking about now, is putting tests on a pipeline so it stops the build going out. And at that point, everyone can see, and it's going back to that shared culture as well. The person releasing this change can quite clearly see something's broken, either update the tests if it's an intended change and it's fine, or to look back on the changes made and refactor that. So that's probably one of the biggest things I've learned. So I found this little graphic on the DevOps Zone site, which helps you kind of show a little bit about what goes into releasing more often. So on the testing side of it, back to kind of what we said about sharing out that that aspect, that quality assurance step, it's got to be done. It can't be a team, it can't be an individual testing. It's got to be shared out. It's got to be automated. We can automate a lot of stuff now. Automated testing isn't as flaky as what it was 5-10 years ago. The approaches to automation has changed with the test pyramid and all of that stuff. So there's so much that can be done with testing, but actually there's loads more to it. You can't just think about testing. There's, like I said, there's branching, there's the architecture, there's releasing, infrastructure, databases stuff. There's so much that goes into this behind the scenes that it's not a testing thing. There's lots to it. So here's some of the bits that I've taken away over my journey for the last 12, 18-ish months. Start. So story slicing, it goes right the way to what work you're going to deliver, how you break your work down, how you get it into the team, how they can slice it in a way that delivers value to customers, and thinking about what the releasable thing is at the end of that. And then it's also on how the team work together, the developers, the QAs, everybody, pairing and mobbing on that stuff. So we don't want 5 tickets in progress, all being done individually. We want teams to be mobbing on 1 or 2, because again, that's just building your confidence on the quality that's going into this stuff. You're always getting a second pair of eyes. There's even with pull requests, which is one method of doing things like this, but that's sending it on to somebody else to have another set of eyes on it. But let's just bring them into the conversation. Let's do it together. Let's pair and mob and all this stuff. Reducing the blast radius. So this is something we look at when we're doing root cause analysis, is how can we limit, if something does go wrong, how can we limit what impact that has to people? So really like interesting thing that I came across and had a conversation with someone about 6-ish months ago was the idea of deploying versus releasing. So there's a fundamental difference there, which I just never even realized. So deploying is all about how you get code from one thing to another thing. That's it. So you can deploy code from test or your Artifactory or whatever it might be to production, but that doesn't mean that customers have to see that stuff. That very much can be hidden, and then you're controlling the releasing aspect of that through other methods. So it's kind of splitting out those 2 steps into 2 individual ones, so you're a bit more in control about how that happens. And one method of that is using feature switches. So again, feature switches aren't a new thing, but they really help, again, with just limiting the impact to when stuff goes wrong. So you could have feature that's worked on for a few days, and you could be releasing 10, 20 times in that period. But you decide after the 2 days, that's when we're going to turn it on for customers. That's when they're going to see it. So that means that you can still do exploratory testing. You can still do all your manual testing and all of that if you wanted to. And you can even do that in the live environment because it's turned off to customers. And we have mechanisms now and tools that allow you to turn it on for certain regions, certain people, IP addresses, all of that stuff. So yeah, it's very much about how you limit that down. And then dark releases as well. Turn it on for a subset of users. I'm sure I heard a story somewhere about how Facebook Messenger was around for months and you had to just stumble across it to find it was actually there. That's a way as well to slowly ramp up this. You can learn by having less of an impact. We're turning stuff on in a big bang method and we're switching it on and everybody sees it and then, oh, it's broken for everyone and your website's down and all of that stuff. You're not really thinking about how to reduce that blast radius. So think how you can limit the fewer amount of customers to get the feedback still. That leads on to actually knowing when it's gone wrong. So kind of sometimes it's referred to as like shift right testing. Is you're monitoring and observability. I hate it when I find out that there's been a problem and we didn't know about it first. So I'm fine. I'm always fine with there being problems in life. That shows that you're doing things and you're breaking things. You're happy to fail. But if someone says, oh, we knew about this before you, or a customer just called us and said that your website's down, that's like a real punch to the gut. We should know about that first, and we should really put all of our emphasis on that. And if we know when it's gone wrong, we can fix it. Like we obviously can't fix what we don't know. So putting all of that focus now on kind of similar to what I said before about not just preventing issues, but detecting them when it does go wrong. And obviously, if you're going to detect them, you need to know how to resolve that stuff. So manual steps of run blocks. If you see this alert, do X, Y, Z. One thing that we've not got to here yet at AO, but something that we are close to in one of the teams and it'd be amazing is if you're automatically deploying stuff, let's say within a 15-minute window of that going out, you start seeing a spike in 500 errors coming back or response times have doubled. Getting that to automatically roll back is just like an awesome step to have in place, because that's the first thing a developer will probably do when they see that error come in. They'll probably look at it and go, oh, hang on, did we deploy recently? Oh yeah, that was 15 minutes ago. Oh yeah, I'll bring that back. And like, let's just take that thought process out and let's just do that fully automatically. So that's one of the next steps that we're going after, which is going to be a real key in all of this. And then it's learning as well. So doing RCA, so root cause analysis, when stuff goes wrong, finding out how that did get through the pipeline, how it did impact customers, what you could do differently, and then taking those learnings and changing the full development pipeline if you need to make sure you're catching this stuff. It might be you need to extend your unit tests, or you might need to put in better alerting for something. You might need to reduce how many people you're deploying, releasing the software out to, but making those changes and learning from that failure. So it's kind of testing is a big part of it, but also all the stuff around the outside as well that helps build up the confidence that if you didn't test your software at all and it went out there, that you know about that and you're fine. So my third tip is to write it down. So I've done a lot of workshops with teams across IoTech, and one of the main parts of that is to actually draw out this pipeline, draw out what it means for those teams. Obviously, we prefer to do that as post-it notes around the whiteboard, but we just use Miro for this. I'm writing down what happens at each of these steps. What do we want to check? Are you duplicating tests anywhere? Is there somewhere early you can detect these potential issues? And all the other bits, so like even just putting a definition of ready and definition of done. That is a part of your work pipeline. So that is not just the technical stuff, that is how you work as a team. So just drawing it out, visually doing it, dragging post-its around, and getting the team to talk about how they release software is just really valuable. And it's just basically building on from like the value stream mapping idea from Toyota, just to, like I said, draw it out, and then having this as something to work towards. And then what we've started doing recently as well is actually translating that into what I'm trademarking now. Really, first is a continuous deployment strategy as code. Everything's as code these days, infrastructure as code and all that stuff. So I'm making this my own. So writing down just in the repo with all the code, with all the tests, what exactly does the deployment process look like for this application? So writing down, you're building and running unit tests, and you can find these here. You got coverage checking here. You're deploying to the environments. Here are the environments this will go to. And then like step 5, you're end-to-end regression testing. So what devices are we testing on there? How does it do it? Where can you find the results? All of that stuff, just in a nice condensed view. So it's always there. It's standardized across repos where you can find that information. Like I said, it's code. So it's code, it's a markdown file. But it's in there with the rest of the code. So it's a living document. It's not just in a SharePoint somewhere that nobody knows how to access or find, and it's stale after 20 minutes of writing it. It's in there and it's living. So that's another key thing I'm trying to work with teams on, just to help, again, bring all this to light and get people talking about it a little bit. Measure it. So for years it's been said we can't measure quality, but I think this is the closest we can get to it, or what I see is the closest we could get to it. And that's using the 4 DevOps metrics, or the DORA metrics, or the Accelerate metrics, 4 metrics basically, which is looking at how often you deploy. So how often is it going from developers' machine, or as an artifactory, to all the way through to production and to end users. And the lead time for these changes. So this isn't your agile work lead time or cycle time. This is your lead time from committing to a repository to it getting out. So if that's 10 days, then you know that there's a testing thing going on there. There's a lot of manual testing involved. If that's an hour, then you can probably consider it in a quite healthy space. You've got a lot of testing automated there. So you can very much see where the improvements can be made. That's looking at the speed side of it. And then time to restore. So when there is an issue, so whether that's a full issue, that's everything's broken, it's down, it's dead, or whether that's just a defect that's impacting one customer, how long does it take you to restore that for back to working state? And then how often out of all these deployments you're doing are you failing? So if you capture those 2 metrics as well, you are then capturing quality. So having those 2 metrics, or those 4, but they kind of go hand in hand with each other a little bit. You could go really, really fast. Everyone can turn on continuous deployment right now, but you'll probably see a spike in all the issues you get, all the defects, all the bugs. And then the other side, you could have completely clean code. It never breaks. It's always 100%, but it takes 6 months to do things because it's so rigorous. So it's very much about keeping those hand in hand. So You can also measure yourself with this stuff. I think this is from Google, so this is what they're kind of thinking about it. So it gives you a benchmark of where you can aim to get towards. This is about 2 or 3 years out of date from what I know. I think those numbers for elite will probably be changing a little bit more to make it more elite than what it is there. But yeah, again, it gives you something to strive towards. And then taking small steps. So I love this image, and it's not just for continuous deployment, it's just everything in life. But it's very much and this is what my mindset is a lot. You think you need to know everything before you can take the first step, but you really don't. You just have to have an idea. We're on a journey with this stuff. At AO, we're probably only a quarter, maybe a third through it. We're just taking really small steps. We're learning. We're happy to make mistakes and fail. We just keep asking in this scenario the teams, like, what happens if we just release this right now? And if people are a bit nervous and a bit scared, like, oh no, I just need Dave to check this thing, or oh, I've not done this, automate it, automate all those things, and just keep asking that question over and over, like, what if this just went out right now? And get to the point where people are just saying, yeah, that's fine, just do it, and just keep going on that journey. So to kind of summarize a little bit, the what is method of regularly deploying software with no human intervention. I think that's well in the textbook definition. Mine is just about building confidence in how we develop and release software for customers. Why? The smaller the changes, the smaller the batch size, and the more often we're doing it, the more safe it is and the more reliable it is as well. And how to do it? I said just talk about it. It's a full culture shift. It is not a technical thing. The technical side of it, anyone could go away now and just spend 5 minutes, make it also deploy to production. That's a very easy step to take. It's very much a cultural shift about how you work and your agile development practices, really. So here's some books that have helped us along the way. My favourite one still all the time is The Phoenix Project. I think it's an awesome book. And some of this very much relates to like the 3 ways that are kind of introduced in that book. That is it.
Awesome. Cheers for that, James. Much appreciated. So I think if there are any questions, please feel free to either just chip in or pop them in the chat. I think just one whilst people are having a think. So in terms of like, I've got a question, but it's kind of like three questions kind of into one, I guess. So in terms of like, if someone was to start from scratch, in terms of tooling, what would you kind of recommend would be the best thing to use? How much would it cost, and how would you kind of justify the cost to stakeholders?
Tooling, there's no real preference on tooling. It's always what's right for the product, right for the team. Yeah, I don't think there's any that are better than others. I'd always think, especially around testing, think about like the cheapest way to learn. So that's not cheapest in terms of money, but like in cost of delay. What is the cheapest way you can get feedback? So think very much about your test pyramid. Think about how you could do it as unit testing, API testing, and then it gets quite expensive the higher up you go. So I think less about the tooling and more the approach. In terms of actual continuous deployment tooling, we use things like Bitbucket, AWS CodeDeploy, but you can use free things. As I think pretty sure GitHub and all that is free. There's Jenkins you can use that's free. So there's loads of cheap ways to go about this if you wanted to. What was your other question?
To be fair, if there's a lot of free ones, then that's absolutely fine, because it was like, how much would it kind of cost, and how would you justify that? But if it's free, I think that would be fine. I think so. So Phil's asked another question. So what is the hardest thing to change in your opinion? The actual technology or the mindset?
Definitely the mindset. Like I said, from a tech point of view, you can flick a switch. That's an easy step to do. The mindset, especially with some developers, I've done one of these workshops with a team, and there's just like, we get it, it sounds good, but there's not a chance for doing it, and they just got really scared and really nervous. And again, just going after that and just finding out, right, tell me what's making you nervous. It's like, oh, I really like that Dave, we don't even have a Dave, but that Dave is testing this and checking this out. Well, okay, well, what if Dave told you he's automated all of that? Okay, and then go after the next thing that's making him a little bit nervous and all of that. So just keep, like I said, take really small steps and just keep chipping away at those questions, and automate as much as you can to help with this.
No, awesome. So yeah, we've got another question from Adrian. So when deploying changes so frequently, how do you know which deployment has caused the problem in production?
So I don't think we've seen that problem yet. We might. So when we talk about how often we're deploying, so that's across our whole estate. So we have hundreds of different repos and projects and all of that. And normally, like, I've not seen changes go out where it's like 10 minutes after each other. So commonly, you have a bit of time between your deployments to see if that one's caused a problem. Also, again, it's like that idea of the releasing and the deploying. So releasing might be a bigger thing, and that might happen every couple of days, depending on what's being worked on. And it's making those conversations around what are we releasing to the customer and how do we kind of collectively work on that and reduce the impact. So it shouldn't be one person's doing this thing over here and releasing all of that, and somebody over here is doing that and that and that. We should be focused as a team on, like, this is the deliverable thing we're giving to the customer, and we should know that that's out there and learn from that. Is what I'd say.
Yeah, no, awesome. To be fair, I'm not too sure if there are any other questions, but one of the things that we do is, so we'll be doing a write-up on this anyway. So if there are any sort of more questions, please feel free to get them sent over to us. So I know that this particular recording is going to be sent out to people, everyone that was sort of attended, and all the people that couldn't make it as well. But yeah, feel free to connect with James on LinkedIn. I'm sure he'd welcome anyone to connect with him. But yeah, I really, really appreciate you doing this talk today, James. But yeah, I think that's it.
Awesome. Cheers, everyone.
Awesome. Cheers to your time, James. See you later, everyone.
Cheers.
Thanks, James.